great, and I appreciate the introduction. It's really, it's nice to be back at Quivira. What a great place. What a great bunch of people. And Sam, I really liked your definition of the radical center, because to me it's like walking a tightrope. You know, you fall off either side, you've kind of lost. And it's harder with some of the current climate that we're in now. The way some people, the polarization that's going on. So it's really fun to be back with some people that are radical enough to look for solutions. So what I'm going to talk to you today about is some work that was done here in New Mexico, and there's people in the room that have been involved in it. Some of the consultants in here, which I don't have listed on here, were very valuable. Guys like Kurt were very valuable in this thing. What we did is we looked at upland, bare ground, and riparian vegetative cover under some different kinds of grazing management. I should have used the word holistic management instead of strategic grazing management for a key reason. It's a hell of a lot easier to say. But there's so many different names for the kind of management, depending on who you talk to, that we're talking about. But basically, the practices are taught by Holistic Management Institute. We're comparing that with more traditional management in eastern New Mexico. The idea being, if all this extra intensive work and planning and monitoring is important, we ought to be able to measure some kind of a change. So that's what we looked at. How do I change this thing? I should have got a diagram. Cool. All right. Okay. And the short answer was, yeah, we saw some real differences. The strategically grazed or holistically grazed or adaptive management, paddock management, whatever you want to call it, ranches, had significantly less upland bare ground and greater riparian vegetative cover than the non-SGM neighboring lands. Upland bare ground cover on the SGM ranches was also comparable to pastures that had been arrested for 3 or more years. And soil carbon levels were also greater under this is kind of preliminary. This is some stuff that Greg's looking at right now. Soil carbon levels were also greater under SGM than under continuous stocking. So the research team included Greg Simons and Eric Sand from Open Range Consulting. They did the field work, they did all the GIS stuff that I don't particularly understand, but I'll try to present to you. We had a really good group of scientists that were helping us with experimental design and analysis. Like I said, we had some input from some guys like Charlie Orchard and Kurt helping us, and Courtney White. And most importantly, we had some participating SGM ranchers. So started out, went out and visited about 10 different ranches, 10 great ranches. For me, the best part of the whole thing was getting to visit these ranches and visit the people that ran them. Tremendous people that are, you could tell are just very committed to good land management. We looked at their ranches, we looked at some of the imagery, preliminary imagery, looked at management records, and finally settled on 4 ranches that we would focus in on that kind of met the criteria that we had developed to look at. Basically, the subject ranches and their neighbors all were still in the grazing business. Subject ranches all managed with strategic grazing management principles or holistic management principles. In fact, all of them I think were trained probably through Holistic Management Institute and had been practicing for 10 or more years. They all began their management after 1972. The reason that being important is that's when Landsat imagery became available. And none of them had excessive juniper or mesquite cover. And so, each ranch is unique, each manager is somewhat different, and they eventually develop what works for their unique piece of the planet. but there were some commonalities that they all shared, right? They all ran few herds. They ran 1 to 3 herds, each herd running through 10 to 30 pastures per herd annually. They had grazing periods of less than 15 days, recovery periods of 3 to 12 months between grazing periods, which actually meant that they're grazing their pastures for probably less than 10% of the year, and the rest of the pastures are recovering from grazing for over 90% of each year. And all of the managers pointed that out as they felt was a very important part of what happens. And then a lot of the other things that come along with that are a result of trying to planning for adequate recovery periods, like things like high density and rapid moves. Stocking rates, the maximum stocking rates that any of these subject ranches reported to us were in the range of 30 to 60 acres per animal unit. But stocking rates vary because all of them go out and do a good fall forage inventory. And based on that fall inventory, particularly here in New Mexico where you have such terrible droughts, sometimes the stocking rate was less. So I didn't even try to calculate kind of an average stocking rate over the last 10 or 15 years that might be influencing conditions today. On the neighboring ranches, they were primarily stocked continuously or seasonally, moderately stocked. We knew some pastures, adjoining pastures, had been arrested for 3 or more years due to the drought that had just occurred. Pastures that they didn't have stock water, or they didn't have forage, primarily stock water limitations, so they just didn't use them for several years. So they had received multi-year rest. And their maximum stocking rates were kind of in that moderate stocking range of 40 to 60 acres per year, probably fairly comparable. Well, 2015, the year we did the sampling, was a very wet year in eastern New Mexico. 150% precip, the kind of year you like, good production, good precip during the growing season, and which translated to really good forage production on both the subject ranches and their neighbors. So the field work consisted of ORC going out on the ground and obtaining ground-based vertical photographs, or as you can see here on the picture on the right, camera on a stick. So they've got a camera mounted on the stick that goes back to a four-wheeler and a computer. What the camera's doing is taking a high-resolution image of a couple of square meters of ground from a known height. So they know and they can accurately develop or calculate the percent bare ground from that image. Here's the 4 ranches we looked at. You can see the number of samples taken on each ranch, number of samples being number of photographs. And ranches ranged in size. There were some of the smallest was about 7,500 acres, up to a ranch of about 66,000. Okay, what they do with the photographs then is they essentially use self-learning software to teach this, in this case, half-meter Pleiades satellite imagery to interpret the ground cover the same as the photograph, because we know what it was from the photograph. So what's that? That's allowing you to scale up now and look at a broader area of land. They hold back about 20% of the photographs to use as a test to test the accuracy, the R-squared value, the correlation. As you can see, bare ground correlated fairly well with the imagery, R-squared 0.9. So once they've got the half-meter imagery classifying the ground the same as the photographs, you can create this bare ground cover map, or a cover map for the entire range, like the bare ground cover map shown in these ranches in the photo on the right. But to do the comparison, what we really want to do is look at what's going on under the 2 different management strategies. So what ORC did was focus in on a 200-meter wide strip running around the boundary of each of the 4 subject ranches. So what you've got is you're looking at a 100-meter wide, let's see if I can make this thing work. Can you, did you have access to, there's a little movie embedded in the picture there. I'm not sure. There you go. Yeah. It's my one little bit of video. But essentially what they're doing is they're comparing the bare ground values on the strip on I don't worry about it. On the ranch side, the SGM managed ranch, the subject ranch with the strip on the other side to see what the difference in bare ground values were. As an example, here's Ranch 3, the JX ranch. And as you can see, it varied around the edge. Anywhere shown in red, for example, the JX actually had more bare ground than the neighboring ground across the fence. Anywhere that was green or blue, he had less bare ground than the areas across the fence. Anywhere you don't see any color at all, either bordered agricultural land or an escarpment, and we didn't use those in the analysis. So within this strip, here's kind of a close-up of it. The red line is basically the boundary fence, all right? So what you're doing is delineating these little polygons, paired polygons, one on either side of the fence. So, each of these paired polygons, if you look at the one above and one below, are the same soil type. They're bordering each other, so they're receiving the same weather through time. So any differences in bare ground we're attributing to management. And so what the analysis involved was comparing the difference in bare ground between each of these 760 some paired polygons. So for the analysis, we looked at compared the SGM strips, lumped them all together, all 4 ranches, compared with the neighboring strips. And then also focused in on Ranch 3 and compared not only the difference between the strategic grazing management and continuous grazing management, but since there were some known pastures that had been rested for a number of years, we compared the difference between strategic grazing management and multi-year rest. 2 of the ranches have riparian areas crossing their borders, which allowed us to do a similar side-by-side comparison on stream reaches under SGM management and the neighboring ranches. And then with the riparian areas, I've also looked at that back through time by making a similar relationship between the half-meter Pleiades imagery and Landsat imagery, which goes back to 1972. We're able to look at riparian vegetation over a 21-year period. I couldn't explain this all that well, but basically what you did is this really souped up Ttest to compare the differences. Combining the 4 ranches, upland bare ground averaged 13% less under the SGM management than on the neighbors. Looking at Ranch 3 alone, upland bare ground was 27% less on the SGM ranch than on the polygons which were still being grazed under continuous grazing. But what was kind of interesting, mostly interesting to me, was it was 9% less than, also 9% less than pastures that had been rested for 3 or more years, suggesting that you could get comparable bare, cover values by doing, the strategic grazing or intensive grazing management, rotational management, however you want to call it, compared to rest. You could have your cake and eat it too. You could pay for the recovery you're trying to get. This shot illustrates how we did riparian analysis. All right, so the figure on the left shows the potential riparian area, what could be riparian, outlined in black, and on a Pleiades infrared image. And then the figure on the right shows the classification developed from that image, where you're essentially, where the light green is showing you the area within the potential riparian area that actually was occupied by riparian vegetation. The tan being areas that were drier, that were riparian, they were upland, more upland vegetation, but with what could be riparian. So it allows you to calculate what percentage of the reach is riparian and what isn't, and compare those. Just shows one of the ranches, Ranch 2, where the riparian areas are coming onto the ranch. In circles here on the left shows the areas that were compared. The bar graphs on the right shows the difference between the intensive grazing management versus the more traditional grazing management. Intensive management being the green bars, and the neighboring stretches being in tan. So as you can see, the riparian vegetation was higher in all cases with strategic grazing management. When we lumped both of the ranches together over the 21-year period, what we found, riparian vegetation was about 20% higher with the strategic grazing management than with continuous grazing. When you looked at that riparian trend through time, it got kind of interesting too. What you're looking at here, the figure on the left, the red line indicates the percent riparian cover under strategic grazing management. The blue line indicates under continuous grazing. The little black arrow shows both of these ranches started doing, the change to the holistic or strategic grazing management in the mid to late 80s. So by about 1990, you start to see the separation happening. And it continues through time. Through time, the strategically grazed pastures have consistently higher riparian cover values. But the other thing you see is that those values under either management strategy really change through time and it tracks precipitation. The graph on the right is annual precipitation through the same time period in nearby Cimarron. So weather's really driving things. I mean, you got a difference of 20% riparian vegetation covered to nearly 60% riparian vegetation covered through time based on weather. So that alone, to me, suggests that the value of looking at these long-term time series analysis. If you'd have done a 3-year study at some point on that line, I mean, you can see for yourself, depending on where you did your more traditional 3-year master study, you might have got totally different conclusions. The other thing that maybe almost looks like is happening here is that it looks like the values kind of converge at high and low values, or high and low precipitation. In other words, when it's just dry, it's pretty hard to have riparian vegetation no matter how you're managing. And when it's super wet, we all start to look pretty good. And as I mentioned, kind of the last little bit of data, Greg's been collecting a little data looking at soil carbon on Ranch 3, and it looks like it tracks as well. In other words, under the more intensive grazing management, you have higher soil carbon than you do under the season-long grazing. This is on the same paired plots. And it's comparable to long-term rest. So again, you can have your cake and eat it too. All right, so is the gain worth the pain? So Todd Sidwell's response, and I think the other ranchers would agree, was that, yeah, it was a lot of work. We had to build pipelines and troughs to water these larger herds. We had to grub out junipers. We had to build 20 paddocks. It was a little, it's management intensive to run one herd, pay good attention, do the planning, run the shorter grazing periods, lengthen the rest periods, and vary the season to use. But the bare ground declined, the forage increased, beef production and land health improved. Stocking rate increased significantly, nearly doubled from the time we bought the place until today. That increase in stocking rate, the more calves produced, plus creative marketing paid for all those changes, and then some. And from an ecological point of view, perhaps what was most important was that the increased soil organic likely initiated a positive cascade. Captured more water, reduced runoff, increased herbaceous production, lengthened the green period. So it was good for the livestock, good for the wildlife, good for the land, good for his bottom line. So in summary, the strategic grazing managed lands had less bare ground, more herbaceous cover. The bare ground values on the strategically grazed lands were comparable to multi-year rest. Soil carbon levels appear to be comparable, also appear to be comparable to between SGM and multi-year rest. And we felt that using the pair plots helped us to separate out weather and management effects. It was a good and novel technique. And we hope that this helps to illustrate the value of large-scale, long-term case studies and better understanding what's going on out there. And thanks to WLA and the Thornburg Foundation, and of course the participating ranches for making this study possible. That's what I've got. Time for any questions, or you want to?
Right up here in the front.
Hi, thank you. I really commend you for you and your research team for completing this study because it's really complex, and I'm in the midst of this kind of trying to promote this kind of management where I'm working right now in Southern Arizona. But it's just really complex to make sure, I mean, for me, to make sure the forage inventory that's collected and then the monitoring that happens after that data collection is one of the most complex things because the pastures we have are pretty large and often compose multiple ecological sites and soil types. So my main question is, how was the forage inventory collected in each grazing unit so that it was representative?
Actually, the guy sitting right next to you, I believe, helped at least two of those ranchers do that. I wasn't involved in doing the forage inventory, but Kurt, I believe, was. At least with Jim. Mike could answer better.
They do all the work, and I've just helped a little bit in advising and some methodology, but basically it's sampling. Much of it is visual versus clipping and weighing. Although there's a bit of both for calibration, particularly in JX Ranch there, and Tom and Mimi, what they do, they actually do clip and weigh. One of the very few operating places that I see that actually do that, but they do all the work to make that happen.
You know, one of the things that I see happen a lot through time, you know, with guys that have, you know, like you say, it's hard to get started, but people that have done it for a while, their eye becomes very, very, very good at looking at the ground. And, you know, I mean, you always want to challenge yourself and make sure you're not wearing your rose-colored glasses or whatever. But to become pretty good at estimating, you know, this is how it looked, this is how many animal days I was able to take off of it, and still, you know, and it ended up looking like how I wanted it to. So they get pretty good at doing it by eye. But I think a lot of folks do, as Kurt said, at least initially, you know, try to pick out representative spots and do some clipping. I guess there's arguments to be made for doing random clipping versus picking out representative spots. But I think in reality, what you want to do is pick up some areas that are representative in the various pastures and then extrapolate from that. You know, you could easily spend more time and money monitoring than you do managing if you don't get too carried away. Yes, sir.
Probably last question, probably.
Okay.
Hey, Ray, was the data refined enough to actually get it down to differences in bare ground by soil type, or did you generically just go with the meter strip regardless of soil type?
Well, you know, the data would be there to look at by soil type, but we didn't look at it that way. We tended to lump things simply because you get more statistical power. You know, you get more degrees degrees of freedom? But that's an interesting question. Might be a good one for Greg, who I think is here. Or at least he was at the bar last night. Well, thank you all. Appreciate it. I know that's kind
Ms. Gordon. There you go.